In this class, we're going to talk about measure of dispersion. Under this, we're going to go over what is meant by measure of dispersion and the types of measure in dispersion. Then we're going to have calculation on each types. Okay. The big question is, what is meant by measure of dispersion? Measure of dispersion is the degree to which a distribution tends to spread about the central tendency. Okay. Now the goals is that we want to measure the variation amongst our distribution. You understand? Our data distribution. Are you paying attention? Do you know when we are discussing in our previous class, we talk about measure of central tendency. Those central tendency, we want to find the center of our data. You understand? In central tendency. But now we are dealing with dispersion. Dispersion simply means variation. So the goals of measure of dispersion is to test the variation in our data set, the degree or extent to which our distribution tends to varies about this from the central tendency. Central tendency simply means the center or the values that is at the center of our data set. You understand? So let's look at types of measure of dispersion. We have the range, we have the semi-quartile range, we have the mean deviation, we have the fourth one, which is the standard deviation. Okay, so let's talk about the range. The range of a given data is the difference between the lower boundary of the smallest score and the upper boundary of the largest score. Okay, range. Please kindly pay attention. Okay, we have the range. Now, mathematically, the mathematical expression for range is h minus L. That is the difference between the, as you can say from the definition, range of a given data is the difference between the lower boundary of the smallest score and the upper boundary of the largest score. Are you paying attention? Please, I want to take note of something. The reason why we have various types of measure of dispersion is because all the types have their own advantage and disadvantage. You understand? Are you paying attention? As far as getting the correct variation or dispersion of our distribution is concerned, all these types of measure of dispersion that are aforementioned measure of dispersion, all of them have their advantage and disadvantage. You understand? For example, it is important to note that range is easy to compute, but it is not reliable because it only takes into consideration the highest value and the lowest value. You understand? So it is not really reliable. Like that is one of the disadvantage. Its advantage is that it is easy to compute. Okay, but the disadvantage is because it only takes into consideration the highest and the lowest. You can see from the definition. So it is not really reliable to measure dispersion, but I'm going to teach you how to calculate the range. Okay, now let's say you are given this question. Let's start with ungrouped data. Okay, let's try to find the range of an ungrouped data. We are asked to find the range of 2, 4, 5, 10, 3, 6, and 11. Okay, that is example 1. Okay, find the range of 2, 4, 5, 10, 3, 6, 11. We are asked to determine the range. Now, how do we determine the range of this number? Don't forget that range is equals to, please pay attention, range, this is for ungrouped data now, range is equals to highest score, are you paying attention? Highest score minus the lowest score. Okay, so the range of this data is, the highest among this data is what? Is 11. You understand? You can see that 11 is greater than all the values that we have in our data set. So the highest is 11. So I'm going to have 11 minus the lowest score. The lowest score among these data set is 2. You understand? So we are going to have 11 minus 2. So the range of the data set is what? 9. If you got 9 as your answer, you are correct. Okay. Now let's have another work example, still on group data. I want to try this. Calculate the range of 4, 100, 142, 150, 86, 1 and 69. Okay, for 100, 142, 150, 86, 1 and 1 and 69. Now, what is the range of this data? I want to try this. Pause the video, then try the question. Now, when you are done, play the video to check whether you are correct. Now, don't forget that range is given by this formula. Now, this formula is for ungrouped data. You understand? Okay? You can see that the data is not grouped. So, this is the formula that you are going to use to determine the range of an ungrouped data. Do you understand? Okay, so let's determine the range of this data. Range is equals to highest score. What is the highest score among our data set? The highest score is 4. Is that so? 4 is not the highest score. You can see. Is it 100? 100 is not the highest score. Is it 142? Well, it is not. Is it 150? Yes, it is, because 150 is greater than all the value that we have among our data set. So here I'm going to have 150 minus, okay? Now, what is the lowest score among our data set? The lowest is 1. So I'm going to have 150 minus 1. So the range of this data set is what? 149. Okay? You can see the reason why range is not reliable is because it doesn't take into consideration all the values that we have in our data set. It only focuses on the highest score and the lowest score, leaving other values out. So that's why it is not really reliable. Okay? So now, having learned how to calculate the range of an ungrouped data, let's look at how to find the range of a group or frequency table, or frequency distribution rather. Now, we are asked to determine the range of the grouped frequency distribution. We have the class interval and we have the frequency of each class interval. Okay? So, looking at the frequency distribution that we are given, how do we determine the range? To determine the range of the frequency distribution, you have to take the difference between the upper boundary of the highest class interval and the lower boundary of the lowest class interval. You understand? Listen to what I just said again, okay? To take the range of frequency distribution, all you have to do is to take the difference between the upper boundary of the highest class interval and the lower boundary of the lowest class interval. Do you understand? Okay? Now, let me give you the formula so that you remember your exam. If you want to determine the range of frequency distribution, use this formula. Range is equals to upper boundary, okay, UCB minus LCB. You understand? Okay? Are you paying attention? Here, UCB is equals to upper boundary of the highest class interval, and LCB is lower boundary of the lowest class interval. You understand? Now, let's first start with the upper class interval is what? The highest class interval is what? 40 to 49. You understand? So, the upper class interval is equals to 40 to 49. Now, we need to determine the class boundary of the upper class interval. You understand? Just listen to the explanation, okay? We are asked to determine the range of this frequency distribution table, okay? And I gave you that range is the difference between the upper class boundary of the highest class interval and the lower class boundary of the lowest class interval. You understand? Now, this is the upper class interval. We need to determine the class boundary. Don't forget, when we are dealing with measure of central tendency, when we are dealing with median, all this one, to get the class boundary, we have to subtract 0.5 from 40 and add 0.5 to 49. You understand? Okay, so the upper class boundary, the class boundary is, let me use mathematics. The class boundary is 40 minus 0.5 and 49 plus 0.5. Okay, so for this I'm going to have 39.5, 49 that is 49.5 as well. Okay, so this is the class boundary of the upper class interval. This is the upper class interval. You understand? The highest class interval. Okay, let's call it the highest. The highest class interval. Okay, the highest class interval is what? 40 to 49. That is the class interval, that is high among all these class intervals. So I determine the class boundary. Now let's focus on the second part. The lowest class interval is what? The lowest class interval is 10 to 19. Okay, so I want to determine the class boundary of the lowest class interval. So the class boundary is equals to, don't forget, we are still going to subtract 0.5 from 10 and add 0.5 to 19. So I'm going to have 10 plus 0.5 and 19. Oh, sorry, 10 minus 0.5 and 19 plus 0.5. Hence, I'm going to have here, that will be 9.5 and 19.5. Do you understand? Okay, so now don't forget that range is the difference. Hello, pay attention. Range is the difference between the upper boundary of the highest class interval and the lower boundary of the lowest class interval. Now, this is the class boundary of the highest class interval. The upper boundary is 49.5 and the lower boundary is what? 39.5 for the upper class interval. Now, please, this is simple. I want you to understand. Okay, it's simple. You just have to pay attention to the explanation that I'm listening to the explanation. Okay, class boundary consists of upper and lower. You understand? The upper class boundary is 49.5 and the lower class boundary is 39.5. That is for the highest class interval. Now, we have determined the class boundary of the highest class interval. In every class boundary, we have the highest and the lowest. So this is the highest and this is the lowest. Now, range is the difference between the upper boundary of the highest class interval. The upper boundary of the highest class interval is what? This is the upper boundary, 49.5. So the range is equals to 49.5 minus the lower boundary of the lowest class interval. The lower boundary of the lowest class interval is what? 9.5. The lowest class interval is what? 10 to 19. The class boundary of the lowest class interval is what? 9.5 and 9.5 to 39.5. 9.5 to 19.5. Now, we want to determine the range, and we know that range is the difference between the upper class boundary of the highest class interval and the lower boundary of the lowest class interval. We have already determined the lowest class interval. We have determined the class boundary. Now, the lowest class boundary of the lowest class interval is what? 9.5. So here I'm going to have minus 9.5. If you didn't understand, kindly listen to the explanation again. So 49.5 minus 9.5, that is 40. So the range will be equals to 40. You understand? So that is the final answer. Okay, so I'm very sure now if you are given a question in the exam, you should determine the range of an ungrouped data and frequency distribution. You'll be able to do it. Okay, so that will be all for this class. See you in the next class.